Okay, I'm gonna get started. Thank you all for coming. I'm gonna talk today about a tool that I developed and is still currently developing. So there, so it's not a full-fledged tool yet, but it like basic proof of concept that I'll talk about today. Riverside, it's a network security visualization tool. So real quick, who am I? I went to the Coast Guard Academy. I'm a Coast Guard officer. I did my first tour at Coast Guard Cyber Command, where I did pen testing and vulnerability assessments primarily, and then helped stand up our red team. And then, oh, and then right now I'm actually a full-time graduate student at the University of Maryland doing my master's in computer science, which is kind of how I started developing the tool that I'm going to talk about today. So kind of why a visualization tool? I get asked this question a lot when I kind of explain people like what I'm working on. So I feel like people can probably hopefully resonate with the pictures on the screen. A lot of times you go somewhere, I used to work somewhere where you ask someone like, well, what does the network look like? Or a segment of the network? Or what does this one system look like? And they hand you a network map and they're like, okay, well, what is this? Like, where is this? Like, oh, I don't know. I'm like, well, how old is this? Oh, I don't know. Like, no one really knows. So I felt like visualizations were something that could help with this and something that people try to use to help with this, but a lot of the really good ones are either behind a very expensive paywall that a lot of people maybe don't have access to. We didn't have any of the fancy tools where I used to work specifically on the team that I worked with that did that kind of stuff that made it easy for us. So that's what kind of led me to develop Riverside. So I actually did interviews with like real people that work either as a network administrator, security analyst, do anything that kind of works with a network, whether that was like specifically security. The drawings here are not what the tool looks like. These are people's like very, very rough sketches of like when I asked them to explain like on the fly, like what would you do? What would you want? Because I wanted something that people would actually want to use, something that had things that people felt like they didn't have with what they currently used or that. So some people were like, I want tables and I want graphics. So the top was like a small graphic. Other people just wanted graphics that were like node link diagrams that show the host with communication. Other people were like, I'd love to see a graph, and if I selected part of it, that had some details about it. Other people liked hierarchical stuff. So like kind of like a top-down view of like what it looked like, how everything's actually connected. So this is what Riverside actually ended up looking like. This is the architecture, at least. I'll kind of show you what it actually looks like in a second. But I actually use agents. Everything is built in Golang on the back end. So the agents in the server are all built in Golang. They're standalone binaries that can run. You can have one agent, you can have many agents. They all send their traffic to the server. I use gRPC to handle everything. I have a database that stores everything that's connected. Right now I use Postgres for everything, but like if you change one line of code in the code that I have, you can make it a different database because I use an ORM to handle everything for that. The front end is all JavaScript. I do have an API to handle session management. I use Gin for that, also another Golang library. And I use WebSockets to handle the communication between the server and the front end to actually send data to the front end from the server. So this is kind of an overview of what the visualization looks like right now. So it's time-based. So Riverside uses time to kind of show what your network looks like at a certain point in time. So the timeline at the bottom is currently showing real time for what I was showing when I took this screenshot. The blue cursor is covering a red cursor that keeps up with real time, but the blue cursor can actually be dragged back in time to show previous states of what the network looked like at that point in time. So it allows you to look back in time as well as keep up with real time as the agents are sending traffic to the server. So I'm going to now just show a quick video if my So this is how Riverside's actually set up from the command line. So I have just a Docker image running of a Postgres database. I don't have anything fancy set up. I have a server that I use. All the configurations are done with YAML files for both the server and the agent. This is just kind of a bunch of the default stuff that I use. And you can obviously change all of these or like have debug running if you want to see like output to like troubleshoot and stuff like that. I'm not running it with debug mode here. This is what Riverside actually looks like on the front end when you like open it up to like log in or to register. I'm not gonna do that for the purposes of this, but this is what you could do. It's set up to handle that. And the timeline at the bottom is showing real time. Since there's no agents currently connected, it didn't have anything on the visualization, but now I'm going to set up an agent also using the same configuration file. And there it goes. There it goes. So I'll set up an agent. These are some of the commands that you can use for an agent to actually connect and listen. You have to use the listen command. Otherwise, you can show different settings, or you can use, I have like a ping in there, just a text for connectivity that sends like a couple of ICMP packets just to make sure it's running. But listen is the actual command that the agent uses to listen and send traffic. So the agent obviously needs root permissions to run, because it does use like the same concept as like TCP dump or anything like that. You need root permissions to run and actually collect network traffic. You have to specify a server. I'm running this locally, and I just use 1533 to do that. But you can give it any kind of server you want. I've tested this like on multiple environments. Like I had on like our little home network where I had the server running on a different computer and set it up for my agent. As long as it can see it, it'll connect to it and run. So now that there's actually an agent, you'll see a little icon come up. Ubuntu was the VM that I was running it in, but that's an agent node. So right now I'm dragging the visualization back in time because I've navigated to a couple of websites and there's network traffic. The red line is still moving because that's real time, but the blue line allows you to go back and forth. You can hover over different things to actually see like more information about that node or that piece of traffic. So like for a remote node, which are the gray nodes, that's just something that's not an agent for the definition of Riverside. So like may not necessarily be remote in terms of your network, but if there's not an agent on it, it's not an agent node. So it's shown as gray by default. I'm gonna switch back. So some of the things that I incorporated in Riverside after like talking to people were that people wanted like some customization options sometimes with the visualization. So I let you can in Riverside change the shape of a node. You can add a label. So if you don't want the nodes like your agent node's default label to be like its host name, which is what it is by default, I changed the one on the left to my host. That's its label now. It'll still show the real host name when you hover over it. It'll still show that. Edges are automatically colored by their protocol. So I have, I think, like 12 that I keep track of. And if it's anything that's like generic, and I use a DPI library, I use Go DPI to actually do that inspection and like determine what the network protocol is. There's a couple that are just gray, or if it can't determine it, it'll also be gray and it'll list it as unknown. But for the most part, it's pretty good at determining like what the protocol is that it's being used. So purple is DNS. The green one here that's shown in the picture is SSL. That was me going to a website and it was sending HTTPS traffic back and forth. I also use node I added a feature of node transparency because some of the feedback I got was that like there's a lot of stuff going on and like an analyst might care more about traffic that happens less often than traffic that happens all the time. So if it's traffic that consistently happens based on the connection or based on the two nodes that are communicating, those nodes will actually get more transparent. So newer nodes that aren't communicated with as often will actually remain like full color or lose their transparency less often. So they're more obvious on the visualization. It shows internal traffic as well as external traffic. It's just a snippet of internal traffic that's happening with SMB traffic that's going between two nodes. I track throughput with packets. I track that, and the throughput gets updated as the communication continues to occur. For edges, if there are double-sided arrows, it means that it's bidirectional traffic. So it's it's two nodes that are talking where traffic is being sent back and forth. I also do it as to or from. So whether the traffic is going to an agent or from an agent, and then I'll just have one arrow designating like which is the source and which is the destination. I'm gonna just quickly show like an example of a video that I used. This is like a quick attack scenario. I won't show the whole thing, but this is just kind of something that I used for some testing. So this is a flat network where like there's no network segmentation obviously happening here. So this is just 15 hosts that are just communicating. The blue line that was there was actually an RDP connection that I was just like I was brute forcing RDP passwords just to like do it. But that's an example where the edge width will actually get bigger as the communication continues. So the longer that a communication occurs, the edge width will actually get bigger, making it more obvious. If it just happens for a couple seconds, you'll see the lines kind of stay pretty thin. But yeah, that's just an example. And then I'll go forward a little bit. So in this, I've changed a couple of the nodes colors because I was investigating them. So like WS02, WS03, file 01, those are all nodes that I was investigating and looking at. So you can change the colors to make them more obvious for you. You can also change the colors of remote nodes. So here I changed the color of this one to red because that was a remote node that I thought was doing weird things. And now it's red on the visualization. And then this is just an example at the end where there's FTP data going from through the network out to another suspicious remote node that I colored red. So there's just a couple of the examples like showcasing some of the features that I added to Riverside as I developed it. So some of the stuff that it doesn't have that a lot of like fancy tools have that I want to add and I'm currently working on because I just, majority of this was actually just developed back in July, June and July of this year, which was like mostly getting the backend working and getting all of that set up correctly where it wasn't like crashing or like with too much data and stuff like that. So just being able to handle all of that. Front-end filtering, so you can filter on the agent. I use Berkeley Packet Filter on the agent. You can do that, but if you want to actually collect all the traffic and then just not see it on the front end, I haven't incorporated that yet. Something interesting that I think would be cool is like timeline standing. So like when you take an action on a node because you think it's like weird or suspicious, being able to like correlate that on the timeline. So whether that's through maybe a stamp that gets inserted, like a little like anchor, or the timeline gets colored, and then as that node communicates, the coloring will continue to the timeline. So that's something that I'm trying to work on right now that I have like some basic code, but have not like fully incorporated into the tool yet. Also kind of trying to be able to handle like network segmentation. So obviously for networks that aren't flat, being able to allow someone to actually see what the network looked like on the visualization correctly. So like all of these nodes should be clustered together because they're in one segment of the network, or maybe using like boxes or something like that that can automatically detect the network segmentation. And then something that, because I have a friend that works at Gray Noise, so I was talking to them about this. So being able to like incorporate APIs like Gray Noise has to be able to do kind of like tell you like, hey, this is a remote node that's communicating internally with your network, and we've seen like bad things with this. So kind of just being able to build something out that adds some kind of, even if it's just a little bit of telemetry on automated threat detection. I don't think visualizations are like a fix-all. This is definitely not something that I would like preach like, oh, you can solve your problems with this, but I definitely think that there's something that can help augment the capabilities that you currently have, especially in maybe smaller places, or even just like for a home network that you want to like see what the heck is going on. So yeah, that's it. This is my contact information. I do have all of the backend code is currently on a GitHub. The front end code I'm going to be pushing soon. I'm just still working out some bugs and stuff like that have happened because I just did my first round of testing on like an actual environment. So I'm just working out some of that. But I do have like the binaries and stuff like that. You can run the server and the agent completely separate if you don't want to run a front end, because all the front end does is wait. And like, so the server can run and you can collect data and mess with it if you want. The binaries are up. I tested it on Windows 10, 11, Linux, Kali, Pop! OS, Ubuntu. I haven't tested it on like Red Hat or CentOS yet, but that's stuff that I'm gonna like have to look through and just double check. So yeah. Yeah, if anyone has questions. Yep. So if I heard it correctly, the question is if I'm ingesting NetFlow data. Yeah, so I'm primarily, that is what it does. It ingests NetFlow data and I store that in the database. I use 3 different tables. I have a host table, which tracks agents. I have a remote host table, which tracks any communication with a remote host that happens, so that I can like track bidirectional traffic with a remote host and not just with internal agents. And I also have a NetFlow table that tracks all the NetFlow data. I haven't tested it with something like that yet, but that is something that I have on my like list of to-dos for testing. That's definitely like, have not tested it on like a full-blown network yet. So definitely small size like testing, and that's definitely something that I need to do just for seeing how different devices work with the agents, because that is something that I don't know yet.
Postgres is APIs modules to actual Postgres versus just the netflow.
So the question was about using Postgres graph. You said graphing utilities like graph APIs. So no, I'm not. Not right now. It's purely just for storage right now. And honestly, all the testing that I've done testing with from 15 nodes of like an internal network communicating externally with I don't even know how many remote nodes up to 30. And I've only needed a Docker image thus far. I have not stood up like any kind of a like a production database to handle stuff yet. Everything's been done with a Docker database. So yeah. Yeah. Okay. Oh, sorry. Yeah, go ahead. Okay. So when I run this on VMs, it hasn't done that, but depending on how it's set up, I would not be able to answer that with 100% confidence. I've run this on a couple of VMs where like I've had VMs on my desktop and then an agent on my actual desktop, and they communicate with each other like they're agents. They don't see each other as remote hosts, but I don't know. Thank you.